Newton built on the work of Galileo and Kepler and came to the conclusion that the motion of falling bodies, the movement of planets, and in fact the movement of any object at any time was due to being acted upon by a force, a push or a pull. He worked out what he called the 3 laws of motion, which govern the movement of all objects at all times and in all circumstances. The first law states that an object's natural tendency is to continue what it is doing. If it is moving in a straight line at a constant speed, it will continue in a straight line unless acted upon by another force. It also states that an object at rest will remain at rest unless a force moves it. This is known as the principle of inertia. There are many examples of the first law. The space probe Pioneer 10 has been drifting through space for 35 years. A hockey puck sliding on the ice will keep on going. And this steel pipe won't move until the claw does its job.
T-minus 10 seconds. 9, 8, 7. Go from 8 engine start. 6, 5, 4.
An object's mass is a measure of its inertia. The greater the mass of an object, like the shuttle, the harder it is to move it or change its direction. Note that physicists use the term mass, or the total quantity of its matter, rather than weight, because in space, all objects are weightless, but they never lose their mass. The second law describes how an object accelerates or changes direction when a force is applied to it. The change depends on the magnitude of the net force. The second law also states that the acceleration due to a given force is always in the direction of the force. The mass of the object is also important. The larger the mass, the greater the force needed to make it accelerate or change direction. The second law can be written as F equals ma. This formula is saying that applied force, or F, equals mass times acceleration, ma. This formula is used to describe the motion of objects under all kinds of circumstances. If a ball is thrown horizontally, it will continue forever unless a force acts on it. The Earth's gravity is a force that pulls on the ball, and it falls to Earth in the direction it is traveling. Newton's third law of motion deals with interacting forces. It states that for every action, there is an equal and opposite reaction. The opposing forces of these two tug-of-war teams balance each other. The swimmer pushes off from the floating raft, propelling his body away from the raft, but also pushing the raft backwards. As the law states, for every action, there is an equal and opposite reaction. A book sitting on a table remains where it sits because the table pushes back with a force equal to the book's weight. This seems like a simple-minded idea, but an architect or engineer designing a building had better understand the third law of motion and ensure there is enough support to carry the weight, or the building will fall down. In the building of bridges, or any complicated structure where weight must be distributed, the calculation of net force is vital because it shows where the stress will be concentrated. This is calculated through vector analysis.